In Chapter 3, Section 4, we're going to look at the chain rule, which is a very powerful rule that we're using pretty much every calculus course. And the chain rule says this: if you have y equal to a function that is a function of another function, so let's say we have a function of g of x, then y prime, the derivative, is the derivative of the what I call the outer function times the derivative of the inner function. So you always have to be taking two derivatives when you do a chain rule, and thinking of it as the outer derivative times the inner derivative. Okay, so let's start with one. It's actually kind of a challenging one to start off with, but we'll look at it. It says f of x equals 1 over the cube root of x squared plus x plus 4. Well, you want to write this as a fractional power to make your life a little easier. So this is really the quantity x squared plus x plus 4 raised to the minus 1/3 power. So that 3 out front will make this a 1/3 power. Now f prime would be equal to the outside derivative, which is, let me see if color can help us. The outside derivative would be the derivative of this, which would be bring the minus 1/3 down, leave the bubble exactly the same, subtract 1 from the power, so it'll become minus 4 over 3, then it's times the derivative of the inside stuff. So times the derivative of the inside function would be 2x plus 1 plus 0. So we're calling those derivative rules. X to the 2, bring the 2 down, subtract 1 from the power. 1x is just 1, and then constants go to 0. So what they have shown down here is the first step we did. So the first step we did was we wrote that as a negative 1/3 power. Then we did the derivative of the outside, where we brought the minus 1/3 down and subtracted 1 from the power and made it minus 4/3. And then they have the derivative, well, we found the derivative of the inside function to be 2x plus 1 plus 0. Now the last step that we haven't yet done is putting it all together. So f prime x would equal, this 2x plus 1 is going to go on top, and then this minus can go in front of that 3, and then it's going to be the cube root of that quantity, x squared plus x plus 4 raised to the 4th. So that's what minus 4/3 is. The 4 sticks with the bubble, the 3 goes outside of the radical symbol, and it's in the denominator because of the minus sign. And I believe that should match exactly what I typed there. 2x plus 1 on top, minus 3, 3rd root of the quantity to the 4th. Yep, that's right. Okay, so that's the first problem. Okay, problem 2 is another one where they kind of guide you along. So they say, okay, we've got f of x equals sine of cosine of tangent of x. And then we have to close off all these parentheses. So f prime, it's going to be the derivative of the entire outside, leaving everything inside the same. So the derivative of sine is cosine, and we're going to leave everything else inside of there the same. Times the derivative, oh, I better not use blue, times the derivative of the next inside term. The next inside term would be cosine of tangent x. Well, the derivative of cosine is minus sine, and we're going to leave everything inside of that the same. So everything inside of that is tangent x. Times, and I'm running out of space here, times the derivative of the last inside part, which is tangent x, and the derivative of tangent x is secant squared x. Secant squared x. So hopefully the color can show us what we're looking for. So let's try to match it up. So they gave us green. Green was this term right here, so we see those match. Then we had to type in the box the purple part, so right there. And then the last part is to put it all together. So we add the red, and then we push together the purple, and we push together the green. So it's just one big multiplication problem. Okay, so that's problem 2 kind of guiding us. And that's how you have to think. Outside, the next one, you're working your way in, and you're just multiplying those derivatives together. They probably are a little easier when we don't have trig functions, and the next one does not, so hopefully it's not so bad. We have f of x equals the quantity 3x to the 6th plus 8x to the 3rd, the whole thing to the 4th. So f prime of x, that's going to equal the derivative of the outside. The derivative of the outside would be 4, leave the bubble alone, 4 minus 1 would be 3, times the derivative of the inside. I see a lot of students want to combine this and they want to bring the 4 down and make it a 3, but then they also want to take a derivative of the inside right away and change those numbers. You leave this bubble exactly the same. Now I take the derivative of the inside, which would be 18x to the 5. So again, bring the 6 into the 3, make it 18, subtract 1 from the 6, plus bring the 3 into the 8, 24x squared. And let's see, I guess the only thing I did was distribute this 4 into each of these terms and write that first. So I wrote it as 4 times 18 is 72, x to the 5th. 4 times 24 is 96, x to the 2nd. So that 4 is gone, it's into these two numbers. Then we can just write the second bubble exactly as it is. 3x6 plus 8x3, whole thing to the 3rd. That should match exactly like that. Okay, that's problem 3. Problem 4 looks maybe scary because it's a trig function, but it actually isn't too bad. So we have f of theta equals cosine of theta squared. Well, f prime of theta would equal the derivative of the outside would be negative sine, leave the inside exactly the same, times the derivative of the inside function, which is just 2 theta. So just pushing it all together, f prime of theta is minus 2 theta sine theta squared. Hopefully you're starting to see this outside-inside nature of these derivatives. Okay, problem 5. We're going to need in this one product rule combined with chain rule. So we have f of t is equal to 9t sine of pi t. Product rule says if y equals f times g, y prime equals f prime g plus g prime f, where f in this problem is 9t, and g in this, so the multiplication is right there, and g in this problem is sine pi t. Well, f prime is easy, it's just 9. G prime is where we need the chain rule. The derivative of sine is cosine, leaving the argument the same, but I have to also multiply by the derivative of pi t, which would be pi. So that's the chain rule part of it. Now putting this all together, y prime would be f prime, which is 9, times the original g, which is sine pi t, plus g prime, which is pi cosine pi t, times the original f, which was 9t. So the only thing left to do is to rearrange things a little bit. 9 sine of pi t, move this 9t up front with this pi, and call it 9 pi t cosine pi t. And that looks exactly the same to me. Perfect. Problem 5. Okay, problem 6. We have y equal the square root of x over x plus 1. Now the first thing you want to do is write this as a bubble, x over x plus 1 to the 1/2 power. Then we can do the derivative as the outside, which would be 1/2, leave the bubble alone, subtract 1 from that power, so it becomes minus 1/2. Now we do times the derivative of the inside. Well, the derivative of the inside, we have to use quotient rule. Quotient rule says if y equals f over g, then y prime equals fig minus gif over g squared. So in our problem, we have the top thing is x, its derivative is 1, the bottom thing is x plus 1, its derivative is 1 as well. So this derivative is going to be f prime 1 times g x plus 1 minus g prime, which is 1, times the original f, which is x, all over g squared, which is x plus 1 squared. Okay, so that inner derivative is a bit of work because it is quotient rule, but we have seen it before. Okay, so let's see what we have here. Y prime is going to equal, we have x in the numerator, 2, that's square root of x in the numerator, and we have, no, this is not right. We have 1 in the numerator so far. This is 2 times the square root of x over x plus 1. Then this is times, this numerator distributing these 1's would be x plus 1 minus x. And that's all over x plus 1 squared. Now these x's are going to cancel, and so we're going to get 1 times 1. So this numerator is all just 1. Now let's see what we have. This is 2 times the square root of x over, I'm going to write this as x plus 1 to the 1/2. And this is times x plus 1 squared. Well, those two bubbles can be combined. You have 2 of them on top, half of them on bottom. So this is going to be 1 over 2 root x times x plus 1 to the 2 minus half, which is 3/2. I believe, yes, you can write it like that. So quotient rule can be a bit of work, but you just got to write everything down and keep track of it. And then these, I know these algebra steps look a little confusing with the fractional powers and negative powers and combining them. But look at what I did here and try to decipher it. If you get lost, let me know. I'll help you walk you through it a little slower. Otherwise, let's move on to problem 7. find the derivative of the function. We have y equals e to the tangent of theta. Therefore, y prime will equal the derivative of the outside. Now, the derivative of e to anything is exactly the same thing. So it's just e tangent theta. So nothing changes until I add the inside derivative. So times the derivative of the inside, which is tangent theta, which we saw earlier, the derivative of tangent theta is secant squared theta. And I believe I just pushed those two things together. So I guess I wrote it a little differently. I put the secant squared first, then the e tangent theta. And I had talked about how it's not easy to get this 2 right there, so you can just write it at the end of the secant, and it will represent the same thing. Okay, in problem 8, they want us to find the equation of a tangent line, which we've done before, but let's review it. First, we're given y is equal to sine of x. Therefore, y prime is going to equal the derivative of this outside, which is derivative of sine is cosine, leave the argument the same, times the derivative of the inside function, which is also cosine. So we get that, and there's no way we can combine that, so you can't call that cosine squared or anything because the arguments of the two cosines are different. But they want us to find this at the point 2 pi comma 0. So we're going to find y prime when x is 2 pi and y is 0. So we're going to get cosine of sine of 2 pi times cosine of 2 pi. Well, sine of 2 pi is 0, and cosine of 2 pi is 1. So we're going to get y prime is equal to cosine of 0 now times 1. But cosine of 0 is also 1. So y prime is equal to 1 times 1, which is 1. And that is the slope of the tangent line. So we recall derivatives are slopes of tangent lines. And the formula we need for the overall tangent line is the tangent y minus y1 equals the slope of the tangent line times x minus x1, where y1 and x1 were given to us as 2 pi and 0. So the equation for the tangent line minus 0 has to equal 1, the slope of the tangent line, times x minus 2 pi. Just substituting in those things. Add 0 to both sides, distribute the 1. Y tangent should be x minus 2 pi. So that would be the equation for the tangent line at that original curve at the point 2 pi comma 0. Problem 9. If f of x equals little f of g of x, and then it basically gives us a bunch of stuff, and it says find f prime of 5. Well, we need f prime. So we take f prime of x. That would equal the derivative of the outside function, which would be little f prime of g of x, times the derivative of the inside function, which would be g prime of x. Now they want f prime of 5. So let's replace all x's with 5. Okay, So we have f prime of g of 5 times g prime of 5. But g of 5 is 0. So f prime of 5 is going to equal little f prime of 0. So we replace g of 5 with 0. Times g prime of 5 is 2. So we replace that whole thing with 2. Now we just need to know what f prime of 0 is. F prime of 0 is given to us as 7. So this whole thing is 7 times this 2 here. So f prime of 5 is 14. Okay, so just use your outer and inner derivatives and then replace your x with what number they give you, and then just look at these values and replace them with numbers. Last problem in this section, we have position. Let's see, a displacement of a particle on a vibrating string is given by the equation s of time is equal to 5 plus 1/2 sine of 5 pi t. They want the velocity of this particle. Well, the velocity of a particle is the derivative of its displacement. So we just have to define the derivative of this. Derivative of 5 is 0. Derivative of this would be derivative of the outside function, which would be 1/2. Derivative of sine is cosine. Leave the argument the same. Times the derivative of the inside of the function. The derivative of 5 pi t is 5 pi. So we get the velocity of this particle is 5 pi over 2. So you can just bring this into this 1. Cosine of 5 pi t. And that looks the same. So that will conclude Chapter 3, Section 4.